next thing is port scanning. We're going to go into networking a bit more. And it is recording and streaming. This is good. All right, so here you are in port scanning. So let's do some banner grabbing. Let me get out of this interactive mode and then make a file called grab.py. And this is going to put in the same kind of networking we've done before. We import the socket library. We create a socket object, and then I connect to this thing on port 22, which is the SSH port, and I just print whatever the server might send me just from connecting. And let me move this window down a bit so that it looks a little better on the Twitch. Yeah, that's better. And then I close it. So I close this, and I run that. Python 3 grab. All right, that goes to my server, and it returns the banner of my server because SSH is intended for this kind of use where you connect, and the first thing it does as part of the protocol is it tells you what version of SSH it's running. So that's a banner grabber. All right, now what happens if I change it so that it goes to a server that doesn't exist? Like instead of going to ad.sam's class, I'm going to go to adw. There is no such server. Control X, Y, enter. So now if I run that one, I get an ugly error message. Node name nor server name provided or not known. That's what happens. It can't connect. It shows you the line of code that failed, but it gives you a fairly nasty error message. So if you want to actually capture errors and avoid seeing those ugly messages, you use the try command. So let me try this. This is grab3.py. All right, so what you do here, let me make my font a little smaller. All right, and there, that fits on the screen okay. So you do try and have a colon. Now you indent the lines after it, so it's going to try to connect, try to print whatever comes back, and then close. And if any of these things cause an error, it's going to go to accept. And then it will take the socket error message and put it in a variable called error, and I can print the error. So this is error handling. Instead of just letting it crash and do the default thing the system would do, I control it and make it do something which I can make under my control and make it look prettier. So that's grab3. I've got to have a G though. All right. And now it just prints that message. Node name nor server name, but it doesn't print the other messages around it. So now let's try grab4. I'm going to copy my grab to grab4. Okay, and now I'm going to edit grab4. All right. And what I'm going to do here is instead of connecting to port 22, I'm going to connect to port 80, and I'm going to go back to a server that does exist. And by the way, this server is in fact serving up a web page on port 80. So it's there, and yet when I run this, it just hangs doing nothing for a long time. The problem here is that the server is up, it is able to complete the TCP handshake, but port 80 is not intended for this kind of interactive work. So when you connect to port 80, it's a web server. It does not have any banner. It doesn't send any reply, so it's waiting for a reply that is never coming. So it's just going to sit there for something like 2 minutes before timing out, and that's annoying. Now what I'd like to do is I'd like to make a port scanner here. I'd like to probe ports and see if they're open or closed. And if I use this kind of code, it's just going to freeze for minutes at a time when it hits a port that's listening but doesn't have a banner. So I have to shorten the timeout. So let's modify that file. And when you define the socket and then you do s.setTimeout to 2, that will give it only 2 seconds before it gives up. Now I leave all the rest of it alone. And now when I run it, 1, 2, there. it only waits 2 seconds, and then it times out. Now, I didn't bother with the error handling, so the message is a little ugly, but still, that's doing a lot better. So now, I might want to use user input. Let's copy, grab 4, put it in grab 5, and let's modify that code to let me adjust the port number. So, I can take it here, I can define a variable called port, and that's equal to integer of input, and here's what it should print for me to see, port number. There. That will read from the user a port number, and then I put that port here. So now I can scan any one port I want. Let's try that. Python, grab 5.py. All right. So if I give it 22, it works. It got the banner. And if I give it 80, it times out. And if I give it a number that's not listening, like 81, then it says connection refused. So here are the 3 possible results of a port scanner. It's open, closed, or not listening. All right. So now I can make a scanner, and now you can find things. So you're going to look through these port numbers ending in 1000, and you'll find one with a certain with a flag on it, and then you can start scanning a whole range of ports. You'll probably need to use a loop, and you'll need to use that error handling, because you're not going to want it to stop when it encounters an error. You're going to want it to just print the message and keep going. And then you have some challenges here that mix all the things we've done so far. This one here, you connect to a server on this port. It will then tell you what port to connect to, and you only have 3 seconds to connect to that port. Then it's going to close. So you can't do it manually. You'll have to read it, parse out this port number, and make a second connection. And here's another one with port forwarding in a similar way. There's a paragraph of text, and the port number you need is hidden in a moving location in there. So you're going to have to do some careful string parsing to find the port. So that's the one I wanted to demonstrate right now. I'm going to stop this recording.